Hey there everybody, welcome back to my YouTube channel. So today we have a really challenging problem that involves the intersection of a quadratic equation and a linear equation. It's going to be a lot of steps, but very exciting nonetheless. So I would just like to point your attention to the description down below where we will have the link for our June SAT crash course where we cover all 4 sections of the SAT, reading, writing, and both of the maths, as well as the link to our SAT math workbook titled No BS SAT Math, very aptly named. Alrighty guys, so without further ado, let's jump in to today's video. Woo! Alright, so let's check out this problem. So we can see that what the question is asking us for at the end of this very long and exciting paragraph is that they want to know what is the value of V. So what we want to notice is that this point right here, V is technically occurring as the X coordinate and W is occurring as the Y coordinate. And this point right here is the intersection point of the quadratic and the line. So this is our intersection point. All right, so they give us some information. We're going to have to piece all of this stuff together somehow to write out the equation of the quadratic, write out the equation of the line, and then of course what it means for the two graphs to be set equal to each other. That's where the intersection point is going to end up occurring. All right, so let's first start out with the quadratic. So the quadratic function, they tell us that the vertex of the graph is 4, 19. So in order to plug that in, we're going to need to know vertex form. If you don't have vertex form memorized yet, pause the screen, make sure to screenshot it, get it up in the noggin because you definitely need to know that for your SAT. All right, so vertex form is written as follows. So we have y is equal to a times x minus h squared plus k. And just to clarify what a vertex is, the vertex is either the maximum point if the graph is like this, or it's the minimum point if the graph is like this. So we can see right here that our vertex is occurring as the maximum point of the quadratic. So h comma k in this equation right up here represent the x and y coordinates of the vertex. So h is the x coordinate of the vertex, and then k is the y coordinate of the vertex. And then this guy right here, A, tells us if the graph is going to be upturned or downturned, and it's also going to give us some information about how wide the graph is going to be. That's not of too much importance right now. All right, so first let's go ahead and plug in the x and y coordinates. So we end up then getting that y is equal to a times x minus 4 squared plus 19. We have 4 as the x coordinate, 19 as the y. And then we need to find out what the value is now of a because we don't have that. So we can use this other point right here that I'm highlighting that they provided for us on the graph of this quadratic to figure out what the value of a is. So let's go ahead and plug that in. So the y here is 3, so 3 is equal to a. The x is 0, so 0 minus 4 squared plus 19. We get 3 is equal to a times negative 4 squared is 16. So let's just actually write that down as 16a plus 19. We'll subtract 19 then from both sides. We get that 16a is equal to negative 16. So a is equal to negative 1. All right, so the final graph of the quadratic, the final equation of this graph is going to be y is equal to negative, because a is negative 1, x minus h squared plus k. And then again, the h and the k we said are going to be y is equal to negative x minus 4 squared plus 19. So that's the final equation of the quadratic. All right, so we got that down. Now we got to find the equation of a line before obviously we can go ahead and set these two equal to each other. So we can find the equation of the line. They already gave us here the y-intercept because this is where it hits the y-axis. So we have y equals mx plus b to model the equation of a line where m represents the slope of the line and b represents the y-intercept, which we already know is going to be equal to -9 because they gave that to us. In order to find the slope, though, we're going to need to do y2 minus y1 over x2 minus x1. So it doesn't matter which of these points we call x2 or x1, we just got to keep it consistent. So let's call this x1, y1, and we'll call this x2, y2. So we get then -1 minus -9 over, -1 goes with 2, so 2 minus 0, that gives us on the top -1 plus 9 is 8 over 2, so the slope is 4. So the final equation of this line then is y is equal to 4x minus 9. All right, so now we finally have the equation of the quadratic. We finally have the equation of the line. Now we're looking for the intersection point, so we're going to need to set them equal to each other. So let's go ahead and do that. That's our final step. So we get then that -x minus 4 squared plus 19 is equal to 4x minus 9. The inside here becomes, let's not forget the negative on the outside, x squared minus 8x plus 16 plus 19 is equal to 4x minus 9. This becomes -x squared plus 8x minus 16 is going to be plus 19 on the outside here is equal to 4x minus 9. Combine the like terms, -x squared plus 8x plus 3 is equal to 4x minus 9. Now we're going to subtract 4x and add 9. So subtract 4x and add 9. We get that -x squared plus 4x plus 12 is equal to 0. And now, finally, we're going to go ahead and factor this quadratic right here. So it's easiest to first divide each of the terms here by -1 so you can get the x to be positive. So we get then that x squared minus 4x minus 12 equals 0. When we're factoring, we're looking for two terms that are going to add to the middle and multiply to the outer. So the only two terms that would do that would be x minus 6 times x plus 2, because -6 plus 2 gives -4. -6 times 2 gives -12 is equal to 0. We get then that x equals 6 if we set each of these equal to 0, and that x equals -2. We can obviously see, going back up here, we got x equals 6 and x equals -2. The intersection that occurs at -2 is all the way over here. This one right here, the x is referring to x equals 6. So 6 is our final answer for the value of v. Oh my goodness, guys, I am out of breath. That was obviously a really long problem. Am I sure why they put this one here with limited time? Absolutely not, but moral of the story, this is how you would approach a question like such on your SAT. Thank you guys so much for watching. So yeah, this problem was a little bit, more like a lot of bit, irritating, but we got through it. So this is how you would handle a question like this. Obviously, this is a very challenging example of the concept, but it does illustrate a fairly good amount. So guys, make sure again to check out the description down below where I'm going to link our SAT crash course, all 4 sections of the SAT covered in our 2.5-hour Zoom course, and our SAT math workbook, No BS SAT Math. Thanks again, guys, for joining me. Hope you learned a lot. Take care and have a great rest of your day.